learn about relative speeds. A relative speed is when some object's speed is affected by something else, and the object is either slowed down or sped up. So when a plane travels from west to east across the United States, the steady west to east winds act as tailwinds, which pushes the plane and makes it speed up. This increases the plane's speed relative to the ground. When the plane travels from east to west, the winds act as headwinds and slow the plane down. This decreases the plane's speed relative to the ground. So, for example, suppose we have a plane traveling at 500 miles per hour as its airspeed, and the wind is pushing against that plane with 40 miles per hour. Then the plane's ground speed is 450 miles per hour. Please pause the video and copy this into your notes. We can write an algebra equation that says the airspeed minus the wind speed equals the ground speed. Please add this to your notes. If we change the direction of the wind speed, our ground speed then becomes 550 miles an hour. Because we're taking the airspeed plus the wind speed to get the ground speed. Please add this to your notes. So let's try a problem. A traveler flies from Charlotte, North Carolina to Los Angeles, California. At the same time, another traveler flies from Los Angeles to Charlotte. The airspeed of each plane is the same. The ground speeds of the plane leaving Los Angeles is 550 miles per hour, and the ground speed of the plane leaving Charlotte is 498 miles per hour. What is the airspeed? What is the wind speed? Here's a picture of what's going on. We can see the picture of the plane traveling from Los Angeles, and it has a tailwind of W. We can see the plane going from North Carolina, and it has a headwind of W. W is the same speed, but it's unknown. That's why we're going to make that our first variable. The airspeed of each plane is the same, but it's unknown, so that becomes our second variable. So let's go ahead and solve this problem. The plane traveling from Los Angeles has a tailwind. So we know the airspeed plus the wind speed is going to give us the ground speed, which we know is 550 miles per hour. The plane leaving from Charlotte has a airspeed that is the same as the Los Angeles plane, and a wind speed that's the same, only this time it's a headwind. So we're going to have to subtract that from the airspeed, and that gives us that plane's ground speed, which we know is 495 miles per hour. Now we have a system of equations. We have two equations, two unknowns. We can solve that using elimination because we have a positive and a negative variable. That makes it fairly easy. Go ahead and solve the systems of equations. Pause the video. Solving the systems of equations, we get the following solution, which means the airspeed is 522.5 miles per hour, and the wind speed is 27.5 miles per hour. Please pause the video, check your answer, and copy this all into your notes. Okay, now it's your turn. Please pause the video and solve this problem. So the first thing I did was drew a picture of the problem. We have the kayaker going upriver with a speed of 3.25 miles per hour, and he's going against the current, and then he's going downriver with the current at a speed of 5.75 miles per hour. That gives us two unknowns, the paddle speed and the current speed. We can set up the following equations. Paddle speed plus current speed equals 5.75, and paddle speed minus current speed is 3.25, and then solve that systems of equations, which gives us a paddle speed of 4.5 miles per hour, and plugging back in, we find the current speed is 1.25 miles per hour. Please pause the video and copy this into your notes.